Let's say you don't have this live in production yet, but you've done some of your prompt engineering here and you want to know, is my setup good or can I create a better setup? You would build an experiment. An experiment is always built on top of a data set. So what we're looking at here is a data set with just input questions in different languages, because this use case is going to be live across different geographies. And we have also something like expected output. Expected output is the annotated output. So a human answer that you're happy with. Then on the left side is where you do the entire configuration of the experiment. So what I'm comparing here is a small prompt with a knowledge base and a large prompt without a knowledge base that holds all the sort of most important questions being asked. So prompt A is the short prompt and prompt B is the long prompt, and I compared across two models, so Haiku 4.5 and Kimi. To run an experiment, it's very important that you did the specking of requirements well at the beginning. You need to know what you're measuring for when running an experiment. So there are some metrics we always measure. Cost, latency, time to first token, we always measure. In the case of chatbots, it's very often very important. Things are not too expensive, it's not too slow. Time to first token is also quick. And then here are several evaluators. So again, a relevance check, a customer response language check, and cosine similarity. For the ones that don't know, cosine similarity just checks how semantically similar the expected output is versus the generated output. And then when I've configured something, I run this actual experiment. I'll quickly make a new run. In this case, quickly run 2 rows to check. Here I can hide a column, I'll hide the messages column, that one is for now irrelevant. And then here I see the responses coming in. Same for the evaluators. So we've ran the experiment, and one more important thing that I didn't mention is we, next to the evaluators, configured human reviews. Because especially in the beginning, it's not only important that we use models or more ML-based evaluators to check if the output is good, but it's also important that a human checks if the output is good, especially in the beginning when you're building these data sets. So what does this look like? What I quickly want to show you is the compare screen, which is where you see a granular overview of what these models actually have outputted over the data set that you gave them. So we had a data set with questions. Here on the left side, we see all the different input fields. So how do I return a package and the expected output. So the expected output in our case is the ideal output. So here, how do I return a package? Here you see actually information returns are completely incomplete in my current knowledge base. Here it does give a recommendation. It's a quite long answer in comparison to our ideal answer, so models are naturally more verbose. Here you do see a way better explanation of what should happen. And then here, very short, knowledge base doesn't include instructions. And here, again, way longer. So what evaluators allow you to do, which you always will see at the bottom here of this compare screen, is they allow you to scale this assessment process. So normally a human needs to look at it and see, okay, do I find this good or do I not find this good? But here you can already see, okay, this is failed. We will always force the evaluators into reasoning, and here you can see the reason. But what I said in the beginning, it's very important actually that you do your own check as well. Do you find this good or bad? And that somebody needs to take the responsibility. Good, correct answer based on a question. Submit. And you can go through all the different data points using these buttons and annotating the entire data set. What is very powerful is our heat map overview. So here you see all the raw transactions, but here you can actually see which model is the cheapest. So Kimi is way cheaper than the rest. Kimi with the short prompt and the knowledge base attached to it. It's way cheaper than running Kimi with the big prompt and a knowledge base attached to it. Well, running Haiku with the big prompt also is far more expensive than running Haiku with the knowledge base. In terms of latency, we see that Kimi heavily outperforms and is way quicker. What's known for that is running on Grok. The Haiku models, same goes for time to token as well. Then the relevance check. It does seem to be the case that the longer prompts where the most important QA pairs are included as examples, are outperforming. And on language check, everything is being passed. Then here for cosine similarity, the best performing model with the highest score is here Gimme with the long prompt. So at the bottom, we show you all these different aggregate values, average, max, median, depending on what is most important for you guys. Also here again, you could do the annotation, but we recommend to do it in the comparison screen. If you have a row annotated here, we again show the count of these different categories, but you could also have a free text or numerical annotation view here of human reviews. So now that you have seen